Great Basic 2 pupil of Vikidyl Models. You're welcome to the second segment of our last term's review. I hope you rested well and you're ready for the conclusion of last term's work. Get your writing materials and be involved in everything we'll be doing today. God bless you. We'll begin with prime numbers. What are prime numbers? Prime numbers are numbers greater than 1 whose factors are 1 and itself. Prime numbers are whole numbers greater than 1 whose factors are 1 and itself. Or you can say, prime numbers are numbers that cannot be divided by any other number except itself and 1. On the screen are examples of prime numbers. All the numbers on the screen do not have any other divisor except itself and 1. So that's why they are called prime numbers. Prime factors. Prime factors are made up of prime numbers. Prime factors are made up of prime numbers. Example, 3 times 5 is equals 15. Here, 3 and 5 are prime factors of 15, but each of them is a prime number. How can we get prime factors? Let's do one example. If you're asked to find the prime factors of 30, let's use 2. 2 goes into 3 once, and we'll be having a remainder 1. So the remainder 1 is kept in front of 0. It becomes 10. 2 goes into 10 is 5. 15 is an odd number, so you don't use 2 to factor as a factor here. We use 3. 3 goes into 15, 5. And equally, remember, 5 is an example of a prime number whose factors are 1 and itself. So we use 5 here. 5 goes into itself once. Therefore, the prime factors of 30 are 2 times 3 times 5. That's how we can get prime factors of various numbers using the factor method. We'll proceed. Fractions. What are fractions? Fraction means a part of a whole of something. A fraction is a part of a whole of something. For instance, the square there has been further divided into 12 parts. Out of the 12 parts, 5 of the boxes are shaded. Hence, 5 is a fraction of the whole 12 boxes. Out of the 12 boxes, only 5 boxes are shaded. So it means 5 is a fraction of the 12 boxes. That is why we're having 5 over 12. In a fraction, we have 2 types of numbers. The number on top is called the numerator, while the number below is called the denominator. I hope you can remember all that. You were equally taught types of fractions. We have them: proper fraction, example 1 over 2. In proper fractions, the numerator is always smaller than the denominator. This case is equivalent to mommy lifting you up. It is very proper because you are smaller than mommy. Improper fraction. Example on the screen here is 5 over 2. In an improper fraction, the numerator is always larger than the denominator. In this case, it seems mommy is asking you to lift her up. That's very improper. Why? Because mommy is bigger than you. Mixed fraction. Mixed fraction is made up of a whole number and a fraction. Here we have a whole number 3 and a fraction 1 over 2. Under fractions, you were taught conversion of fractions. Conversion of fractions. We'll take this again. Under conversion of fractions, you can be asked to convert 12 all over 5. What does this mean? This means, how many times can you find 5 inside 12? Let's try counting that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many groups of 5s are in 12? 1 group, 2 groups. So the 2 groups makes the whole number. And the remainder there is 2. The 2 there becomes the numerator, while 5 there is the denominator. So converting 12 over 5, we will have 2 whole number 2 over 5. 12 over 5 is an improper fraction, while 2 whole number 2 over 5 is a mixed fraction. I hope we understand that. Let's proceed. We also have here addition of fractions. 3 over 9 plus 4 over 9 gives us 7 over 9. How did we achieve this? Where the denominator is common, you do not add the denominator, you only add the numerators. Here the numerators are 3 and 4. So 3 plus 4 gives us 7. So we have the fraction 7 over 9. 7 over 9, just as you've seen on the boxes there, means 7 boxes out of 9 are shaded. So 7 over 9 is a fraction of the shaded boxes. 7 over 9 is a fraction of the shaded boxes. 2 of the boxes are not shaded. So 2 over 9 is the fraction of the unshaded boxes. 2 over 9 is the fraction of the unshaded boxes. But since we were dealing with shaded boxes, the final answer there is 7 over 9. Let's do one example of more example on addition or maybe subtraction of fraction. Let's erase this. If you are asked to solve 9 over 13, take away 5 over 13. Over here, we are still having a common denominator. So when we have the common denominator, you leave the denominator where it is. So we say 9 take away 5. We'll be left with 4. So this is under subtraction of fractions with common denominator. In the third term, you'll be taught addition and subtraction, multiplication and division of fractions with varied denominators. So I hope you'll be prepared for that. As it stands, we have come to the end of our last term's review, and I'm sure you really enjoyed the class. Ensure you pay attention anytime you're having lessons, so that, of course, you will understand. Finally, let's take our evaluation. You'll be expected to answer these questions, snapshot the answers, and post it on a private chat or my personal chat or even in the group chat, however you want it. Ensure you're involved. Ensure you do the evaluation. And don't just do the evaluation, send it to me. Either by doing a soft copy, snapshotting it and sending it back on the chat, or you ask mommy or daddy to bring in the hard copy to the office. I'll be pleased to mark and evaluate you. Ensure you're involved. Question 1 says, list 4 factors of 12. Question 2, List the prime numbers between 52 to 100. Question 3. Divide 24 balls to 3 children. At this point, I say, remember to stay safe. Bye-bye.